Okay, this is section 3.3, and you're going to watch the video notes and take the notes. Before you do this, I want you to get a note card. Or if you're doing this at home and you don't have a note card, you're going to have some type of straight edge. A ruler's fine. But in class, I'm going to have you use, sorry about that, I'm going to have you use a note card. And I want you to use the same note card all the whole time we're graphing. So I want you to get a note card and I want you to write your name on it. Okay? I'm going to write my name and I'm going to write Mrs. Detlefson's graphing note card. Okay, you'll see why here in a second. But you're going to be using this a lot, so don't lose it. If I can find some fun colors, I'll go see if other teachers have fun colors and you can have, pick a fun color. But keep it. All right, so here. So we're talking about horizontal and vertical lines. And there's this acronym, HOY, H-O-Y. And then, I believe it's VUX, V-U-X. Okay, when they talk about HOY, H means horizontal. Oops, I spelled that wrong. Oh my gosh. Horizontal. Now, this O, it looks like an O. This really means your zero slope. So remember, horizontal line, it's a zero slope. Then, that's where your Y, so Y equals a number. And that means it crosses the y-axis. So for example, if you get y equals 4, that means, if you have an x and your y, that means y is 4 every single time, no matter whatever the x is. The x can be -2, it can be 0, it can be 2. But because this is your x and this is your y, you plot those points like -2, 4, 1, 2, 3, 4, 0, 4, 2, 4. When y equals 4, it crosses the y-axis at the 4. 1, 2, 3, making sure that's 4. Then you're going to take your note card. So your line is a horizontal line with a zero slope. So when y equals a number, on your y-axis here, wherever that number is, it's going to be a horizontal line. So when y equals that number, it's like that. And when you use your note card, when you graph, do all the way through your graph and then put arrows at the end, meaning it can go on forever. Now this one, vertical, it's your undefined slope. And then it crosses the x-axis. This means x equals a number. So when x equals a number, it's going to be a vertical line, an undefined slope, and this is where it crosses the x-axis. Sorry. So x is 3. That means x is going to be 3 the entire time. It doesn't even matter what y is. Y can be 2. It can be, -2, 0, 2. So we're going to go to 3. 1, 2, 3. It can be 3, 0, 3, 2, 3, -2. But your line is going to be a vertical line. Use your note card for a straight edge. Just because you want a nice straight line. And you want to go through your entire graph that it's shown. Don't just stop in the middle. So whenever you have an equation like this, that's what's going to happen. You're going to have a straight line. Well, they're all going to be lines, but it's either going to be horizontal or vertical. Okay, now here's where some of us heard this last year, some of us did not. I'm going to act as if nobody has heard this. We can actually graph a line using the slope-intercept form, meaning this equation, y equals mx plus b. M is your slope, and then b is your y-intercept. Now we talked about why they use m, but never really understood why they use b. And I know I've looked it up before, and I don't even know if they had an answer. But what we're going to do is we're going to find at first the slope, the m, and the y-intercept of each function. So all we're going to do here is identify, when it's written in this format, the slope and the y-intercept, which means that this 3 is the slope, which means it's like 3 over 1. This, the -4, is your y-intercept. Now we're going to graph those. So your m will equal, and think of it as 3 over 1 when we talk about slope. And the -4, your b is your y-intercept. Okay, so right now we're just identifying the m and the b, so your slope and your y-intercept. Now this one, y equals 6. Think of this, there's no x, so think of that as 0x plus 6. So this one has a slope of 0 and the y-intercept of 6. So m is going to be 0, b is going to be 6. Okay, this one, negative x, so this is really saying negative 10x plus 0. So your slope is negative 10, and you can think of it as negative 10 over 1. You can write just negative 10, but this is I'm going to show you why I want you to think of negative 10 over 1. And then your b, your y-intercept is 0. So just looking at this is in what we call slope-intercept form. It has your slope and your y-intercept. And then identifying the parts are going to be important because we're going to use those now to learn how to graph. Okay? We're going to graph the equation. Now what the graphing of the equation does, it shows us the solutions that would make an equation true. So I'm going to come back to this here in a moment. But we're going to start down here. So looking at this equation, y equals negative 3x plus 4. Negative 3 is your slope. Now if you want, rewrite this formula, mx plus b. That helps you. Your slope is a negative 3. Think of that as a negative 3 over 1. Then your y-intercept is 4. Okay, now, when we graph this, we're always going to start with the y-intercept first because you need to know what your starting point is. Now, when the y-intercept is 4, that means your ordered pair is 0, 4. So this is your x and this is your y. So your y-intercept is 4, so it's going to start 1, 2, 3, 4. It's going to start here. Then your slope is a negative 3 over 1, which means now it's a negative slope. This is a negative slope. So I know my line has to go downhill. This top number means I can go up 3, 1, 2, 3, but I'm going to go over 1, and I'm going to go to the left because I know I need the line to go downhill. Now here's what I'm going to do. I'm not even going to plot just one point. I'm going to go back to my y-intercept. I'm going to do it again. 1, 2, 3, but this time I need to go to the right because I want my line to go downhill. I'm going to go 3 more. 1, 2, 3, go to the right. 1, 1, 2, 3, over 1, down 3, over 1. I'm going to do that all the way through my graph. Okay? I'm going to do that all the way through my graph. So then I'm going to, oh, where is my note card? I'm going to take my note card and I'm going to make a straight line. Now, if you don't have a note card, use some type of straight edge. And in fact, you could take your paper and turn it and use that as a straight edge. Okay? So I want a straight line and I want you to go all the way through. Do not just do a line here because I want to see now what this is representing. These are representing, that line is representing the solutions to that equation. Okay, so the line represents solutions to the equation. Because looking at this, sorry, can you guys see that? Line represents the solutions to the equations. You have 2 variables, but you only have 1 equation. 2 variables and 1 equation, that means you have to plot it on a coordinate grid because you have multiple answers that can happen with x and y. Okay, so let's try this one. So let's look at what we did first. We first have to identify the slope and the y-intercept from the equation. So the slope is 2/3. The y-intercept is a -1. So what we did, we have to identify the slope and y-intercept. Identify the slope and y-intercept. Then start with your y-intercept. Okay? You can write your y-intercept as an ordered pair if you like. That's going to be like 0, -1, because it's the y-intercept. So you can, let's just do plot your, or the, not your, the y-intercept. And you can do this as an ordered pair. It's always going to be 0 and then whatever your y-intercept is. Because that's saying 0, -1. So 0, -1 is plotting here. It's going to be on the y-axis. Then do your slope. Now remember, it's rise over run. So when it's 2/3, that means from here it's going up 2 spaces. So space, space, so 1, 2, and then, now this is a +3. So I'm going to go up 2 and to the right 3. The reason I know it's right because I want it to go uphill for positive. I can go up 2 over, up 2 over 3. And then over here I need a plot. I don't want you just to do 2 plots and think it's straight because it'll probably get off. So go down 2, left 3, down 2, left 3. So your dot should go all the way through your graph. Okay, all the way through your graph. All right, so do slope over and then, okay, and go way through, all the way through the graph. Okay, all the way through graph, that's what that says. Okay, so then we're going to also look at the domain and range. Now, on these, we could pick any value for x. They're not limiting us on what values to use for the x. Remember, your domain is your x values. So these domains are going to be all real numbers because I could pick any number for x. And you can do that all real number sign if you want. Then your range is also going to be all real numbers because whatever you pick for x, if it's all real numbers, then it's going to be all real numbers for range. So you can also do the all real number symbol like that. Same thing here. We're not limited to what we're told. We'll see a limitation here later, but you have all real numbers for domain and all real numbers for range. And we'll work more on this, so don't stress about that. I want to really focus on the graphing and slope-intercept form. Okay, again, this line represents a solution to that equation. Okay, so over here it'd be easier. If I plugged in 2 for x, -3 plus 2, or -3 times 2 is -6 plus 4, and that's going to be a -2. Okay, so this line represents a solution to that. All right, so now we're going to practice this. Let's do this in the second video because I'm going to run out of time in this one. So we'll do a second video for finishing this.